Hello and welcome to the Academy. So in this video, we are going to understand the AWS Glue Snowpark project. Let's understand the objective of this project. So the goal of this project is to automate the extraction, transformation, and loading of sales data of multiple countries into Snowflake using AWS Glue and Snowpark for seamless processing. Now let's see understand the data sources. So these sales order data files are stored into a Git repository with different formats for each of the countries. So currently we have three countries data. One is India, of which the data is stored into a CSV format. We have the sales order data from USA, which is stored into a Parquet format. Also, we have the sales order data from France, which is stored into a JSON format. Now, let's understand the ETL process. So what we are going to use is for the data extraction and storage, we are going to use AWS Glue and S3 bucket. So we will use the AWS Glue to execute a Python script that is going to connect to your Git repository. Once it connects to Git repository, it is going to extract all these three country sales order data, which is stored into a different format into a GitHub and load into your S3 bucket. This will once this data is loaded into your S3 bucket. Now we will use the Snowflake feature of Snowpark to extract the data from our S3 bucket and load into the respective database and schema inside our Snowflake. For that, we are going to use Snowpark. So the data loading in Snowflake will be done through Snowpark and the staging schema. So what we are going to do, we are going to write a Snowpark logic, which is first going to run a copy command, which is going to take the data of each these three different files and load into three respective table inside your staging schema inside your Snowflake. After the initial validation of this data, we will move this data from our staging to the raw schema. Inside the raw schema also, we will have three different tables for each of the respective files. Now, once the data is in the raw schema, we will apply some of the transformations by using the Snowpark capability uh, to transform this data and move this data to another table inside our transformed schema. So what type of transformation we are going to apply? So what we are doing is we will rearrange some of the columns. Also, we are going to rename some of the columns because few of the columns in each of the respective files have a different naming convention. So what we are going to make sure that all these different columns will have a same name once the data gets to our transformed layer. We will add some new columns like country columns so, to identify that, okay, from which particular country this data is coming in our transformed table. Now, there are some of the columns where we have multiple values setting into the same column. So what we are going to do, we are going to split those columns into multiple columns inside our transformed table. Once we all apply all these transformation on individual data, we are going to union all these data set and create a global sales order table inside our transformed schema. The last step is that we are going to do aggregation and final storage. So we will apply additional aggregation logics on our transform data, and that final curated data set will be loaded inside the respective table inside our curated schema for any reporting and analytical purposes. So what is the outcome as part of this particular project? This pipeline will ensure that you understand the structured, automated, and efficient ETL process to manage any kind of data which are stored into a different format for and this help you allowing an easy analysis and reporting within Snowflake. You're also going to learn the Snowpark concept of Snowflake, that how do you write a data frame concept inside Snowflake using Snowpark. Uh, so this is the entire project overview before starting the projects. Thank you. Hello everyone. So in this video, we are going to set up the IAM role required for our AWS Glue Snowpark project. This IAM role will be used by AWS Glue uh, to access the data from an external URL where we have the data set and then load the data to our AWS S3 bucket. Since this role will be used to access an S3 bucket, we are going to provide an S3 full access to this role. Along with that, we also want to see the logs of our AWS Glue job whenever they are running inside AWS, so that we can debug any issues in the future. So for that, we are also going to provide CloudWatch full access to this IAM role. So to create a IAM role in our AWS, first we need to log in our AWS Management Console. Once we are in the AWS Management Console, in the search bar, search for IAM, and you should be able to see an option of IAM. Just click on that to open the IAM dashboard. Once you are in the IAM dashboard, you should be able to see an options of roles, users, and policies. So we need to create role. So on the left hand side, if you see the roles options here, just click on that. And to create a new role, we simply click on create role. Now, first thing we need to provide is to trust entity to this role. So the trust entity is nothing but where you are allowing some of the services of AWS to call to perform action on other services of AWS. So this role will be used by AWS Glue. So what we are going to do, we are going to provide uh, AWS Glue an access to perform activities on S3 bucket, also on the CloudWatch, because we are going to give the policies of S3 and the CloudWatch to this role. So under the trust entity type, select on AWS services, and under the services, we need to search for Glue and click on the Glue. Now, what we are saying that allow Glue to call AWS services on your behalf. So, if so, based on this particular trust policy, the Glue will be access to other AWS services. Now, once you select Glue, click on Next, and now we need to provide the permissions to this particular IAM role. So, in the search bar, first we need to provide the S3 full access. So, in the search bar, search for S3 full access. You should be able to see an Amazon S3 full access. Just select that. Now the second one, we need to provide the CloudWatch full access. So again, in the search bar, search for CloudWatch full access, and you should be able to see CloudWatch full access. Just simply select that. Once you select both of the policies, click on Next. Now, under the name review and create, we need to provide a name to this role. So I'm going to call this as uh, Glue Snowpark role. Okay. If you want to, and the description is already there, and now we need to review that whatever we have given, it's correctly given to this particular role or not. So under the select trust entities, we see that we have given the Glue to assume this role, and under the permissions, we have given the S3 full access and CloudWatch full access. Once you verify these details, scroll down and click on create role to create your new role used for this new project. So once you click on create role, AWS will automatically create your Glue Snowpark role, and that's how we are going to set up our IAM role for this particular project. Thank you. Hello and welcome to DE Academy. So in this video, we are going to set up the S3 bucket required for our AWS Glue Snowpark project. So to create a new S3 bucket, first log into your AWS Management Console. Once you are in the AWS Management Console, click on the search bar and search for S3. You should be able to see an option of S3. Click that to open it. Once you are in the Amazon S3 dashboard, you should be able to see all the previous buckets if you have already created. To create a new bucket, simply click on Create Bucket option over here. Under the general configuration, you need to pass the bucket name. So I'm going to call this bucket as DE Academy Snowpark Data Bucket. You can rename your bucket as per your own convenience. Once you pass the bucket name, rest all the configuration will be kept as default. You scroll down and you should be able to see an option of create bucket. So simply click on that to create your new bucket. So once you click on create bucket, the AWS will successfully create your data bucket, and this is how we are going to set up the S3 bucket required for our AWS Glue Snowpark project. Thank you. Hello and welcome to DE Academy. So in this video, we are going to set up a job inside our AWS Glue. which is going to extract the data from a Git repository folder and upload into an S3 bucket. So let's see what type of data we are moving. So this is the Git repository where we have these three files sitting under the Snowpark data folder. Uh, so we have a data from three different countries, and this data is the sales order data. So we have the data from France, we have the data from India, and we have the data from USA. And all these three data sets are stored into a different file format. So France data is in JSON format, the India data what we have received in the CSV file, and the USA data is in the Parquet file. Now let's see what type of information these files stored. So if I open this india.csv file, I see the details. What we have is like order ID, customer name, mobile model, uh, how much quantity they have purchased, what is the price per unit, and what is the total price, if there is any promotion code applied on that, and other information like the order date and the payments and the shipping details. So pretty much all the three files are have the same details, but they are stored into different file format. So by using the glue, what we are going to do is we are going to extract all these three files from this Git repository folders and put into our S3 bucket. So to set up a Glue job, first log into our AWS Management Console. Once you are in the AWS Management Console, click on the search bar and search for Glue, and you should be able to see an option called AWS Glue. Just click that to open it. Once you are in the AWS Glue dashboard, click on these three lines item what we have, and you should be able to see an option called ETL jobs. So just click that. Once you are in the ETL AWS Glue Studio, you should be able to see three options called by creating a job. One is the visual ETL, the another is notebook, and the third one is the script editor. So what we are going to do is like we are going to create a Python script, and using that Python script, we are going to connect our Git repository and extract all the three files from that particular folder and put into our S3 bucket, which we have created in the previous step. So to create a Python script, click on this script editor. Once you are in the script page, you should be able to see an option to select an engine. Since we are running a Python code, just click on this drop down and you should be able to see an option called Python cell. So just select that. And another option, you need to select the start fresh. Once you select both the options, click on this create a script button, and AWS Glue Studio will automatically create a blank script for you. Now here on the script page, we need to pass the code, the Python code, which is going to uh, connect to our Git repository and extract all those files and put into S3 bucket. So this code is already provided in the document. You just simply copy paste that code over here. And we need to change few details. The one detail what you need to change is the bucket name. So this is the bucket name which I have created for this particular project. So that's why I am passing this bucket name. You need to change this bucket name as per whatever bucket name you have set it up. Rest all the details will be as it is. So let's understand what this code is doing. So first it is importing all the required libraries to run this Python code. Here I am passing all the Git repository details, that what is the repo for that particular Git repository, what is the owner for that repository, what is the folder where we have all those files. We don't need to change anything over here. Now here we are passing the bucket name. So as I previously mentioned, you need to update this bucket name with the name whatever you have created in your previous step. Then what we are doing, we are first initializing the S3 client, and then we are fetching all the files from your Git repository, and then we are uploading those files from the Git repository to our bucket which we have passed above. So this is a simple code which is doing extraction of the file from Git repository and putting into an S3 bucket. Now once you copy the script and update your bucket name, simply click on the job detail where we need to pass certain details like name of the job and the role through which this job is going to execute. So first I'm going to give a name to this role. So I'm going to call this as Glue Snowpark job. And under the IAM role, we need to select the role which we have created previously. So click on this drop down and you should be able to see that role called Glue Snowpark role. So just select that. Once you pass the name and the IAM role, rest all details can be as the default, and then we need to click on save button to save this particular script. So once you click that save button, AWS will successfully save this particular job. Now we need to execute this job and see if to move the files from our Git repository to the S3 bucket what we have set it up. So to run this job, simply click on this run button. Now our job is successfully started. Now to see the execution of this job, click on this runs tab, and you should be able to see there is a job instance which is already running. So just refresh this particular log to see. It will take 15 to 20 seconds to execute these jobs and then upload the files to our S3 bucket. So let's wait for that time period to get this job successfully completed. So now our job is successfully completed. Now we need to go back to our S3 bucket and see if our files has been uploaded to the bucket what we have created. So for that, simply search for S3 in the search bar and you should be able to see an option of S3. Right click and open a new tab and go to our S3 dashboard and search for the bucket what you have created. So I have created with the name called Snowpark. So just select that bucket, and once you select that, you should be able to see that all the three files from your Git repository is now successfully uploaded to your S3 bucket. So this is how we are going to set up our glue job and create the Python script, and using that Python script we are going to copy the data from our Git repository to our S3 bucket. Thank you. Hello and welcome to D Academy. So in this video, we are going to set up the IAM role required by Snowflake to integrate with our AWS account so that it will be able to access the files which we have uploaded through the glue jobs in the previous step. So to create a new IAM role, simply first log into your AWS Management Console, and once you are in the AWS Management Console, click on the search bar and search for IAM, and you should be able to see an option of IAM. Just click that to open it. Once you are in the IAM dashboard page, you should be able to see an options to create roles and policies. So we need to create a new role. So just click on this roles button on the left hand side, and you should be able to see all the previous roles what you have created. To create a new role, we need to click on this create role. Now under the select trust entity, we need to select the trust entity type as AWS account, and under the AWS account, we need to select these options of require an external ID, because this is the best practice when a third party application is going to assume this role. Since we are going to this role will be used by Snowflake to assume our AWS account. That's why we wanted to provide this external ID. So just click on this external ID, require external ID checkbox, and you need to pass. As of now, we will pass a default external ID. When we create the setup in our Snowflake environment, the Snowflake will generate an external ID, and we need to take that external ID and put it back to this particular IAM role. So as of now, just give a default ID as 000, and then you need to click on next. Under the add permissions sections, we need to add the permissions to this particular IAM role. So this IAM role will be used by Snowflake to access the data from our S3 bucket. So this particular role needs to have an access of S3 bucket. So in the search bar, search for S3 full access, and you should be able to see an S3 full access. Just click on that and click on next. Under the name, review, and create section, we need to provide a name to this role. So I am going to call this as Snowflake Snowpark role. Okay. If you want to provide any description, you can provide that description over here. Now we need to review all the details what we have passed as part of this IAM role. So under the trust entity, we see that okay, we have an external ID where we have passed the value as 000 as of now. Under the add permission, we have Amazon S3 full access. Once you verify all the details, scroll down and you should be able to see an option of create role. Just click on that and you should be AWS will be successfully created. This is Snowflake Snowpark role for this particular project. So this is how we are going to set up the IAM role required by Snowflake to access our AWS S3 buckets. Thank you.
Hello and welcome to the Academy. So in this video, we are going to create the integration between our AWS account and our Snowflake account so that we should be able to access the files what we have uploaded into our S3 bucket using the AWS Glue to our Snowflake tables. So to create this integration, first log into your your Snowflake account. Once you are in the Snowflake account, click on this project button and you should be able to see a worksheet option. So just click that, and we need to create a new SQL worksheet so that we can write all the SQL statement to create the respective databases, the schemas, and the tables inside those schemas where we are going to upload the files from our S3 bucket. And then we will create the storage integration to create this integration between our Snowflake and AWS account. So simply click on this drop down button and you should be able to see an option called SQL worksheet. So click that. It will create a blank worksheet. Here we can execute our SQL statements to create our database and schema. So first, let's go ahead and create a new database. So this database I'm going to call as Snowpark DB. So we are going to execute a statement called create or replace database, and the name of the database is Snowpark DB. So simply select that and click on this execute button. It will able to it will able to generate a new database for you. And to validate that, simply refresh this page and you should be able to see this newly created database over here. Now, once you create the database, we will go ahead and create 4 different schemas, and these are the different schemas where we will store different types of data. So I'll explain what these schemas are going to store that. So first, we need to select the database, and under that database, we are going to create our schema. So I'm going to run the statement called use database, the newly created database. So simply select that and execute that. Now your database is set to Snowpark DB. Now under that, I'm going to create 4 different schema. One is staging schema, another one is raw schema, the third one is transformed, and the fourth one is curated. So staging schema, this is where I will create all the tables which is going to store the data by running the copy command to upload the data from S3 bucket. Okay, so whatever data we get from S3 bucket, we'll upload into the tables inside this stages schema. After that, we will have a raw schema. So raw schema will be the schema where we'll contain all our raw data. So this will contain your historical data of raw data. Now the third one is the transform data. So whatever data, we will apply some business logic to transform that. If you want to store that data, we will store in the tables inside this particular schema. The fourth one is the curated schema. So this is the data where we will store any curated or aggregated data coming from our transform data. So these are the 4 schema which we are going to create as part of this project. So I'm going to simply select all 4 of the statements and execute that. And Snowflake will be able to create all the 4 schema. Now to validate that, simply refresh it. And if you click on this drop down, you should be able to see your all 4 schema. So staging, raw, transformed, and curated. Now we have created our 4 different schemas where we want to store all the different types of tables. Now we need to create the respective tables in which we are going to store the data coming from these different files. So for that, we are first going to, and these tables will be created under the staging schema. So what I'm going to do is, like, I'm going to first select the schema. So I'm going to run a statement called use schema snowparkdb.staging. This is schema where I'm going to create the respective tables in which I'm going to load the data from my S3 buckets. Now once you select your respective schema, you should be able to see the schema over here. So this is the database and this is schema where I'm going to create all the respective 3 tables of the similar structure what the files have. So now let's go ahead and create those 3 tables what we have. So as you have previously seen in our Git repository, we have 3 types of files. One is the India sales files, one is the US sales files, and another one is the France sales file. So India sales files is in the format of CSV. So we have all these columns inside our CSV. So I have taken the names from that CSV files and I've created these columns name here, and the data type of all these columns are going to be varchar because we are loading the data from a file. So we want to store everything as a varchar into our Snowflake. So let's go ahead and select this statement and create this table. So first I'm going to create my India order CP table. So this is successfully created. Now my US sales order CP will have a Parquet file. And to store a Parquet file, we need to create a variant data type column inside our table. So that's why I have created a variant data type column called source data. So now let's go ahead and create our US sales order table. Now the third one is the France sales order CP table. This table is going to contain the data into JSON form. And to store the JSON data, we also need to create a column called of a data type called variant. So that's why I've created the source data column name as a variant. So let's go ahead and create these three tables. Now all the three tables are being successfully created. Now to validate that, simply click on this refresh page and go to your staging schema, and you should be able to see all these three tables: the India sales order CP, the France sales order, and the USA sales order CP. So these are the three tables in which I'm going to load the data from my S3 bucket by running the copy command that we see later part of the videos. Now, once you set up the database, the schema, and the three tables required to store the data, now we need to create the integrations so that we can create a link between our Snowflake and AWS account. So for that, first we need to create our storage integration. So this is the code to create our storage integration. It's simple: create or replace storage integration, and the name of the integration is Snowpark_int. Here what we are saying that we are going to store the data from our S3 bucket. Now here we need to pass the role of the IAM role what we have created previously and the bucket from where we are storing the data. So to get this IAM role, we need to log into our AWS account. So let's go ahead and log into our AWS account. Once you are in the AWS account, simply in the search bar search for IAM, and you should be able to see an option of IAM. Just click that to open it. Once you are in the IAM, click that role options what you see on the left hand side. So click on the roles, and you need to search the role what you have created for our Glue Snowpark project. So I have created the role name as Snowflake Snowpark. So this is the role what I have created. Whatever the name you have given to that role, just search for that role name here. So once you see that role, just click that, and you should be able to see an ARN over here. So this is the ARN which we need to pass into our storage integration in Snowflake. So simply click on these two square button, copy the ARN, come back to our Snowflake, and you need to paste this ARN over here. Okay, so simply delete entire thing and then paste it. Now we need to pass the S3 bucket where we have the files from our Git repository. So for that also, let's go back to our AWS account, and in the search bar, search for S3. And you should be able to see an option of S3. Click that. Once you are in the S3 dashboard, search for your bucket name what you have created for this project. So my bucket name having a name called Snowpark in that. So I've simply searched that. Whatever name you have given, search for that name. Once you open that, click that over here, and you need to copy the ARN of this particular URI of this particular bucket. So simply select any one of the file and you copy this S3 URI. Once you copy that, come back here and you need to paste this value over here. So simply place that, and you need to remove this file name because we want to give the access to this storage integration till this particular bucket, and under this bucket we need to access all the three files. So you don't need to provide the file name, you just need to giving the S3 colon hyphen and the bucket name over here. Once you pass these two information, simply select this one and execute it, and your Snowpark integration will be successfully created. Now once your Snowpark integration is created, we need to create this trust relationship, we need to get the IAM role and the external ID of this Snowflake account what is being generated as part of creating this integration and put into our AWS IAM role. So for that, we need to simply execute a statement called describe integration and the new integration what you have created. Okay, so simply select that and execute it. you should be able to see the different attributes of this particular integration. And in that case, we are only interested in two values. One is this uh, storage AWS IAM user ARN and the storage AWS external ID. These are the two values what you have to take and go back to your AWS account, and you need to paste these values inside your IAM role. So let's go ahead and go back to our AWS account, and in the search bar search for IAM. Open this IAM again here and click on the roles and search for the Snowpark roles what you have created. Okay, so this is the Snowflake Snowpark role which I have created. Just simply click that. Once you are inside the role page, you should be able to see an option called Trust Policies. So click that. And here we need to click on Edit Trust Policy. Once you are in the edit page, first you go back to our Snowflake and copy the value of storage AWS IAM user ARN. So copy this one, and you should be able to see this value. Click on this square button to copy the value, come back and delete everything what you have in the line number 7. So whatever is your inside these two double quotes, delete that and paste that value. So this is the IAM role which you have got it from your Snowflake, because your Snowflake is also mounted on top of an AWS account. So whenever you create any integration, it will generate an IAM role, and that is the IAM role which you are coming back and putting into your AWS, your own AWS account, so that it create a trust between your Snowflake account and your AWS account. That's what we are doing over here. Now we need to get the external ID. So this is the external ID. So go back to your Snowflake and you need to get the value of line number 7. This is the external ID. Copy the value of this external ID, come back to your AWS account, and you need to delete this external ID which you have passed while creating it and paste the value. Now once you update these two values, click on update policies. Now by doing this, you have created a trust relationship between your own AWS account and your Snowflake account, where you have created the storage integration. Now, once you create this trust between your AWS and Snowflake account, now we need to create the external stage. So external stage is through which you are going to access the files from your S3 bucket. So this is the command what you have to run. So what I'm doing is like create external stage into this database, this schema, and this is the name of my stage, which is I'm calling as Snowpark underscore stage. This is the storage integration which I'm using. So this is the Snowpark underscore int, and this is the URL of S3 bucket from where I am trying to access the data. And this is the same URL what you have passed into your integration also. So simply select this particular command and execute it, and your stage will be successfully created. Now once you create this stage, now you need to validate that whatever setup you have done, the trust what you have created between your AWS account and Snowflake account is working as expected or not, right? So when you try to access the data or the files what you have in S3 bucket from your own Snowflake account, you should be able to see those files if the integration is done properly. If there is any issue, you'll get an error. So to check that, what you have to do, you just need to list down all the data what you have into this particular stage, because this stage is created on top of this S3 bucket. So whatever you have into this particular S3 bucket, you should be able to see all the files. So if I run this particular statement, I should be able to see all the 3 files what you have, which I have uploaded as part of my previous step by using the AWS Glue services. So simply select that, and you should be able to see all the 3 files. This is the France sales order, this is the India sales order, and this is the US sales order. These are all the 3 files what I currently have on my S3 bucket. So if you are able to see these 3 files successfully, your integration is successfully completed, and we can move into the next break. So this is how we are going to create integration between our AWS account and Snowflake account, and also we are going to set up the respective tables into respective schema, where we are going to load the data from the files by using the copy command. Thank you.
Hello and welcome to the Academy. So in this video, we are going to write our Snowpark code. This Snowpark code is going to load the data from our S3 buckets to our staging layer tables using the copy command. Once we have the data into our staging layer, then we will move this data to our raw layer tables by using the data frame concept of Snowpark. So to create the Snowpark code, first log into your Snowflake account. Once you are in the Snowflake account, click on this project button on the dashboard and you should be able to see a worksheet option. Just click that. Now here, since we are writing in a Snowpark code, Snowpark is nothing but a data frame inside Snowflake. So we need to create a Python worksheet. So to create a Python worksheet, click on this drop down and you should be able to see an option of Python worksheet. So just click that. Once you are in the Python worksheet, the Snowflake will automatically populate a sample code for you. So just go ahead and delete this section. Here we need to select our database. So we are going to run our code inside Snowpark DB and inside our staging layer. So just select your database and schema accordingly. Now under the setting, we need to see what is our handler. So handler is where from where the code is going to start. So we need to update this as a main. So we'll keep that as a default. Now this Snowpark code is expecting a return time. When it is execute, it is expecting to some return to Snowflake. So click on this drop down and you should be able to see string variant and table. So as of now we select a string because we will populate a message once our Snowpark code is successfully executed. Uh, so after updating these two values, now your Snowpark uh, blank script is ready to write you the code. So simply go ahead and copy the code what we have given in the documentation and come back here and paste it. Uh, this is the code which is going to first load the data from our S3 bucket to the tables inside our staging layer by running a copy command. Once the data is in the staging layer, then we will move this data from staging layer to the table inside our raw layer. Now let's understand what this code is doing. So first, it is importing all the required libraries from our Snowflake.snowpark package, similar to what we do in Python. In the second step, what we are doing, we are first setting up the schema where all our staging tables are present. So I'm running a command called use schema snowparkdb.staging, and then I'm doing a truncate on all our copy table inside our staging schema. So by running a simple SQL statement, you can execute all these commands inside your Snowpark also. Now in the third step, once your tables gets truncated inside your staging schema, then I'm doing a copy into my respective tables uh, to the from the respective files setting into my S3 buckets by using the stages what we have created in the previous video. So the India sales order CP table is getting loaded from the India sales order.csv files what we have into our S3 bucket. The USA sales order CP table is getting loaded from the Parquet file which contains the USA sales order, and also the France sales order table CP table is getting loaded from the France sales order.json file, which is in the S3 bucket. So these are the three copy command which is going to take the data from the files which we have in our S3 bucket and load into the respective CP tables inside our staging schema. So these are this is the step number three. Once you have the data inside the step number four, what we are using the concept of data frames in Snowpark to first create the data frame and then use that data frames to write our the data inside our raw schema. So what I'm doing here, first I am selecting all the data from my India sales order CP table, which is in the staging layer, and creating a data frame out of it. So if you see, this is how you can create a data frame. Now, once you create the data frame, what I'm doing is I'm writing this data inside this particular table inside our raw schema, and the mode is override. So every time when I'm writing this data into my raw schema, I'm overwriting this. So this is my India sales order table inside my raw schema. Similarly, I have done for the USA sales order data. So since the USA sales order data is in a Parquet format, what I have to do is like I have to flatten this Parquet file by using the features of Snowflake to make it a structured rows and columnar way. So that's how I'm flattening this Parquet file from the data what we have in the CP table, and then again writing that same data uh, setting into this data frame inside our raw table of USA sales order. Similar to that, the France sales order data is in the JSON file. So what I'm doing, I'm using the feature called lateral flatten to flatten the entire JSON and making them in more of a columnar rows way. Once we have the data into structured format inside our data frames, then I'm writing the same data frames into my sales France sales order table inside the raw schema. So this is what the Snowpark code is going, which is first truncating all the copy tables, then loading the copy tables from our S3 buckets, and then once you have the data inside your staging copy tables, then I am using the data frame concept of Snowpark to creating the respective data frames and then writing that data frame to the respective tables inside the raw schema. So once you paste this code, simply click on run here, and it should be able to successfully execute and create your respective tables inside your raw schema. So let's go ahead and check once this code successfully runs. It will take a couple of seconds to execute. Meanwhile, you can just refresh this page, and if you expand your Snowpark DB, you should be able to see. Uh, as of now, we don't have any tables here because the data is still running. The code is still running. Keep on refreshing. So let's wait. Now, if you see the tables, you have your India sales orders. Now, if you refresh this page, you should able to see all the three tables, and you'll get a successful message saying that your Snowpark code to load the data from raw tables to staging is successfully executed. So this is how you are going to move the data from S3 bucket to one of the layers inside Snowflake, and using the same Snowpark code, you are moving the data from one schema to another schema inside the Snowflake. So this is how you are going to write the Snowpark code inside Snowflake. Thank you.
Hello and welcome to the Academy. So in this video, we are going to write the Snowpark code, which is going to read the data from the table what we have loaded in the previous video in the raw layer and apply some of the transformation which we want to do and then load this data into one of the table in the transform layer. So to create this Snowpark code, first log into your Snowflake account. Once you are in the Snowflake account, just click on this project button and you should be able to see an option of worksheet. So just click that. Once you are in the worksheet page, since we are going to write a Snowpark code, we need to create a Python worksheet. So just simply click on this drop down button and you should be able to see an option of Python worksheet. Just click that and it will generate a blank worksheet with a few of the sample code written by the Snowflake. So let's go ahead and rename this worksheet so that in future, if you want to go back and check that this code, you should be able to identify that. So to rename this, just simply click on these three buttons and you should be able to see an option of rename. Just click that and you can call this as transformed layer code. Once you rename that, simply delete the default code which is generated by Snowflake, and let's go back to the documentation. And we already have a given a code to you. Just copy that code and come back and paste it here. Once you copy the code here, now before running this code, we need to select the database and schema. So just click on this drop down and you should be able to see the database as Snowpark. So select that, and the schema we want to select as raw. So select that. Once you select the database and schema, under settings, we need to make sure that our handler is always main, and the return time we can change as to string. And because we want to, once this code runs, it will say a successful message, and that's the return type what we are sending from this particular code. Now let me explain what this code is doing and what transformation we are doing it here. So if you see, first I'm importing all the required libraries to execute this code. Once I have all those libraries, what I'm doing, I am defining a main function where first I am setting up the schema as snowparkdb.raw. So this is the schema which I'm going to send, and this is the first transformation which we are doing. Here what we are doing is we are ordering the columns in a sequential order, because all the columns into the three respective raw tables what we have loaded inside the previous video, the India sales order, the US sales order, and the France sales order, the columns are not in a sequence. So what we are doing is we are making sure all the columns are being in a sequenced way, so that we can union this data and create a one table where it is going to contain all the data of these three countries. So first we are running a select statement where we are selecting the columns in an order from India sales order,
And also what we are doing is we are renaming few of the columns and adding a country column. So by using the rename function of our Snowpark data frame, what we are doing is in the India sales order, we have a column called GST, and also we have a column name as mobile. So what we are doing, and these two columns are not there into the text column is the GST column is called as a text into the US sales order and the France sales order, and the mobile number we are renaming it as a contact number. So with the help of the rename function of the data frame in Snowpark, what we are doing, we are renaming the GST column as text column and the mobile column as contact number. So this is how we are renaming the columns, and then we are adding a country field because we want to identify when this all this data gets union. We need to identify that which data has came from India file, which data has came from USA files, and which data has came from the France file. So that's why we are adding a country column inside that. So for India sales order, we are adding the country as India with the help of with column function of the Snowpark data frame. So similar to that, we are renaming the phone number of our USA sales order data frame with contact number, and also adding a country called USA inside that. And similar to that, for the France also, we are doing the same activity. So this is the first transformation where we are making the columns in an order. We are renaming some of the columns, and then we are adding a country column to identify each data set. Once we have all these data frames combined here, then we are doing all the union of all the three data sets. So first we are doing a union of India sales order and USA sales order, and we are creating one data frame. And then again, with this data frame, we are unioning the France sales order. So this is the final data frame which contains the data from all the three data frames what we have built on the top. Now the third transformation what we are doing is adding some of the default values to the missing column. So in the data set we have observed that the column promotion code have some null values. So what we are doing is we are filling those null values with NA column. So that's the transformation we are doing with the fill NA function of the Snowpark data frame. Now we in the data set we have seen that the mobile model column contains the data into with splitted with the hyphens, so that data has values like the brand, the version, the color, RAM, and memory. All these data set is combined into one column. So what we are doing, we are splitting that data into multiple columns here, and by using the split function of our Snowpark data frame. So by splitting this one, we are creating multiple columns. Once we once we create all these columns, then what we are doing is we are doing the order of the columns in a way in which we want this data set to be written into our transform layer. So we are defining all the columns in an order, and then along with that also what we are doing is we are adding a new column called insert dts, where we are populating the value as current timestamp. So this will be the final data frame with the order in which we want the columns, along with the new columns called insert date. Once we have this final data frames, what we are doing is we are writing this data to a table called global sales order inside our transform schema under the Snowpark DB. So this is the entire code. Now let's execute that, and we will see the data into this global sales order. See all the transformation is being applied correctly or not into this data set. So simply click on this run button, and you should be able to execute this code. So it will take a couple of seconds to write the data into the final table, and you will see in a message that if your code runs successfully, you should be able to see the message as code runs successfully, because we have given this message at the end once your code executes successfully. Now let's go ahead and refresh this page and see if the table is successfully created under the transformed schema. So go to on Snowpark DB, under Snowpark DB, open the transformed schema, and under that you should be able to see a table called global sales order. So just click that and click on this option, and you should be able to preview this data. So click on that, and here you should be able to see all this data here. So let's see what all transformation we have done is been applied correctly or not. So here you see the mobile model has been splitted into multiple columns where we have the mobile brand, mobile model, mobile color, RAM, and memory. This is all been splitted. Now here if you see in the on the promotion code, we had some null values, so we have defaulted those null values as NA. And now if you scroll on the right hand side, you see the column as from GST is been renamed to tax, And also you should be able to see a new column called contact number, where we have renamed the phone and mobile column from respective country's data as a contact number. And also you should be able to see a new column called insert data has been inserted into this data frame. So now your table is successfully loaded. So this is how we are going to write the Snowpark code to apply some of the transformation on the raw data and create a new transformed table with all the transformation. Thank you. Hello and welcome to the Academy. So in this video, we are going to write the Snowpark code, which is going to read the data from the transform table, which we have created in the previous step, and it's going to create certain specific curated tables inside the curated schema. So to create this Snowpark code, first log into your Snowflake account. Once you are in the Snowflake account, click on this projects button. Under the projects, you should be able to see an option of worksheets. So just click that. Once you are in the worksheet page, click on this drop down and you should be able to see a Python worksheet. Since we are going to write a Snowpark code, we need to write that code into Python worksheet. So just click that to create a new Python worksheet. Now, once you open a blank Python worksheet, let's go ahead and rename that by clicking these three buttons and click on rename, and we are going to call as curated layer code, so that in future if you want to see the code, it will be easy for you to find out. Once you rename this sheet, now we need to select the database and the setting in which we want to execute this particular Python code. So just click on this drop down and you should be able to see database as Snowpark DB, and here we want to run this particular code inside our transform schema. So select the transform schema. Once you select the database and schema, under setting, make sure your handler is main, and the return type we are going to select as a string, because we are going to pass a successful message once the code is executed successfully. Now, Snowflake will automatically create a sample code over here. So let's go ahead and delete this code because the code is already given in the documentation. You can just copy that code from there uh, and paste it. So let me copy this code from my document, and here that code is. So let me explain what this code is going. So first, what we are doing is we are importing the required libraries from the snowflake.snowpark module, the and different functions like column function, sum, year, quarter, to date, concate, and lit functions we are importing from this particular library. Once we have these libraries imported, what we are defining is the main function, where first I am setting up the schema in which I'm going to execute this particular Snowpark code. Now, as part of this particular script, we are creating three different tables. So let's see these tables one by one. So first, I am creating a table where I am only showing the records from my transform table, which is this global sales order, if the shipping status is delivered. So by using the data frame concept of table and the filter functions, what I'm doing is I'm selecting all this data from this global sales order, and then I'm putting a filter on this where shipping status is delivered. So it is going to fetch all the records from this global sales order table transform schema where the shipping status is delivered, and it's going to create a data frame. And then what I'm doing is I'm writing this data frame to a table inside my curated schema, which I'm going to call as global sales order delivered. So this is the first curation what I'm doing, where I'm only storing the data where the shipping status is delivered. In the second curation, what I'm doing is I am selecting the data from global sales order, and I'm grouping the data based on two columns. One is mobile brand and mobile model. So what type of which particular brands has been sold, and what is the models under that brand has been sold, and what is the total sales amount for those particular brands and the models. That is the aggregated data what I'm generating as part of this particular code, where I'm using the functions of Snowpark such as group by and aggregated functions, and creating a data frame out of it. And then I'm writing this data frame again back to another table inside the curated schema, which is I'm calling as global sales order underscore brand. Now, the third curation, I'm doing this similar activity. What I'm doing, I'm grouping the data based on the country, and then what I'm doing is I'm generating the year and the quarter based on the order date what I have in the data. With the order date, what I'm doing is I'm concatenating a prefix as Q1. So what is the year in which the sales happen and what was the quarter in which the sales happen? That is the information along with the country. I am grouping that data on based on that, and then I'm calculating the total sales volume. That means how many mobiles for that particular quarter has been sold and what was the total sales amount for those mobiles. So that's the aggregation what I'm doing and writing into a data frame, which I'm calling this global sales order country, and then I'm writing this data frame data again back to another table inside the curated, which I'm calling as global sales order country. So these are the three accurations what I'm doing as part of my curated code. So now to execute that, simply click on this run button, and Snowflake should be able to execute this code and create those respective three tables inside your curated schema. Once your code runs successfully, you should be able to see a message that the code has been ran successfully. Now to validate that, simply click on this refresh page, open your Snowpark DB and go to the curated schema, and you should be able to see all these three tables. Now let's verify all these three tables one by one. So first, I created a table where I am only putting the records where the shipping status is delivered. So just click on that and click on these three dot buttons and click on preview data. And if you scroll on the right hand side, you should be able to see the record of all these. All these records have a shipping status as delivered. So if you scroll down, you should be able to see all the records have shipping status as delivered. So that's one curation. Second, I did a aggregation based on the brand. So this is the table which I have created in a curated schema. Now click on this three dot button and click on preview data. Should be able to see these are the different mobile brands which we have sold, and these are the models of that particular brand, and these are the respective total sales which happens respect to those brands and the models. Now the third one which we have created is we did the aggregation based on the total quantity and the total sales based on the country, year, and the quarter. So this is the table where I have loaded that data. So simply click that and click on these three dot button and should able click on preview data, and it will be able to see that okay, these are the three countries from which we have received the data. This is the particular year and the quarter in which we have this total sales volume and total sales amount respectively. So this is how we are going to write a Snowpark code, which is going to read the data from our transformed schema and create curated or aggregated data inside our curated schema. Thank you.